Hello friends, welcome to the Electrical and Instrumentation Engineering YouTube channel. In this channel we will learn about the electrical and instrumentation related topics in three languages, that is English, Hindi and Kannada. Let's move for the topic today. We are going to learn about the PLC courses. It is the part 2. In the previous part we have learned that the wiring diagram of PLC analog output, PLC analog input module, digital output module, digital input module. How the modules are configured in the PLC rack. This is what in the previous video we learned. In this video, we will learn about the wiring diagram of PLC I/O modules. How wiring diagrams can be made in the PLC diagram. This is very useful in the industrial application. Let's go into the topic. Move into the topic now. First, we will learn digital input model. So, what is the digital input model? Let's learn. This is called the digital input model. So, this one I have missed. Here, the model OK means the power supply is OK and the user supply is OK. It consists of a 24 volt DC and 110 volt DC. If both supply are OK, then this indication lamp will be glowed. And this is 16 channel digital input model. See here, it is given in the nameplate list I1, I2 up to the I16. It means it can collect up to the 16 input digits, 16 inputs from field devices. Now next move into the further detail about the digital input model. So see what is the inside the digital input model, how digital input model looks like. See here digital input model. Digital input model will looks like this one. So inside this terminal there are total 70 number of terminals present, total 60 number of inputs. One is the neutral, which is useful for the indication lamp inside the input model. Let's move into the next slide now. Now we will apply the neutral to the 17th number of TB in the digital input model inside. See, in 1 to 16 consists of a digital input model which collect input from the field devices, and the 17 is the 0 volt DC which is to be connected to the digital input model. Now after completing this, we will add one relay. See what happened from field. We will receive the power supply, where we will receive the power supply and relay will act. And the relay consists of a 24 volt DC common in the relay supply. And when the relay gets energized, at that time the common and NO will become NC. At that time, what happened? The power supply, the 24 volt DC power supply will flow from this into this end. Now neutral is through here, and this lamp will energize, and PLC will energize by this address I001. This is how input digital works. Let's see with the example now. Yes, now we are having a example, real time example. See here we are having a push button. So what happened here having push button? When we press this push button, the contact will close. The 110 volt DC supply is available in the NO contact. Okay, when the contact will close, these both contact will close. So what happened then? 110 volt DC supply will feed from the fuse terminal to this terminal, return back, and it will actuate that relay, because the relay already consists of a 110 volt DC neutral supply is already connected. Only 110 volt DC required, which is connected from the push button. From this circuit, we are connecting 110 volt DC through push button. The relay will act. When the relay will act, 24 volt DC available at the common point, see here, and this common point will turn to NC contact. When the relay will act, common point will turn to NC contact, and the supply will go. This bit will energize. That is I001. This bit will energize. This is how the electrical input model will PLC input model will work. After completion of digital input model, now we will focus on the digital output model, which is also very useful in PLC. See, this is the digital output model. It looks like same digital input model. What happened in the digital input model? The supply received from the field, but in the digital output model, the supply will through from this device, this terminal, and the relay will act, and from the relay, the supply will through to the field devices, and field devices will act accordingly. The same is a model supply is okay, and when the user supply is okay, then the both LEDs will act. And there are total 16 channel digital output card. This is the, hence it is mentioned the I1, I2 to I2 I16. So actually it should be O1, O2 to O16. Hence please do correction to this. So there are total 16 outputs will generate from this output model. So let's go deep into this model. So what is the inside the digital output model? Let's see. It as I already told that it looks like similar to the digital input model. See here there are total 18 number of terminals present in the digital output model. So 1, 2, 3, 4 up to 16 is it use output model, and the 17, 18 is connected to the power supply. That is a 24 volt DC power supply connected in these terminals. Let's see how the 24 volt DC is connected in this terminal in the next slide. Now we see, now here we see. So there are 24 volt DC and 0 volt DC bus bar is available in the PLC panel, and the 24 volt DC is connected to the positive 24 volt DC is connected to the 18th channel, and the negative 0 volt DC is connected to the 17th channel. Hence that the module is energized now. Now it is ready to give output. When the program gives a output command from the in the PLC, then the model will give output device. See how output it gives. Let's see in the next example. Here we see. See here in this relay, the relay is reversed here. As in the case of digital input model, the relay received power supply, relay coil receives power supply from field devices. But in the output model case, the relay receives coil supply from the digital output model itself, because the relay consists of a 24 volt DC coil. Hence, the 0 volt DC is connected to the commonly 0 volt DC is connected. So now what to do? So 110 volt 24 volt DC is required to act the relay. When the program gives command, PLC gives command from this terminal Q001, so this will act. Then the relay will act. The power supply is connected here, and it will move from NO contact to the field devices. Let's see how it practically works. With the example we will see in the next slide. Yes, now you see we can easily understand. The PLC will give command from 24 volt DC. That is the terminal 1. The PLC will give command, and then it will receive 24 volt DC in the positive terminal. However, the negative terminal of the relay is connected to the 0 volt DC. Then what happens? This relay will get acted. So when this relay will get acted, the common terminal already consists of a 110 volt DC here in the common point. When the relay will get acts, the common and NO contact become this NC contact, and it will through from fuse terminal, glass fuse TV, and glass fuse TV it will go into the indication lamp. Indication lamp is a one of the output device in the PLC. There are many multiple contactors are available, solid valves are available, and many power contactors are available. Many types of output devices are available, but in this case we used for an indication lamp. And when 110 volt DC is reached to the positive terminal of the lamp, the negative terminal of the lamp is connected to the 0 volt DC. When positive terminal, negative terminal are connected to 110 volt DC, then this lamp will get turned on. This is how digital output model works. Now the next device is to learn, that is the analog input model. So what is the analog input model? And in the previous slides we have learned the digital input model and digital output model. Digital means it will give only one power supply, that is a 24 volt DC, either from the field it receives or from the model it will give power. In the analog input model, what happens? There are a variable parameters are available in the field, like temperature, pressure, and many other, and like temperature, pressure, flow, current, or voltage. And there are many factors which are varying in the field devices. So varying field devices require to read the PLC through 4-20 milliamps power supply. So 4-20 milliamps power supply shall be fed from the field devices, which may be transmitters or transducers, anything. So this is how we are going to learn in this section, that is the analog input model. This is a very important topic in the PLC section. Please watch video till the end. Let's move into the detail of the analog input model. So how analog input model works. See, what is the analog input model consist of? Let's see. This is the analog input model. There are the total 16 number of channels are available, but this is not a 16 channel. This is the 8 channel analog input. Because what happened in this analog model, it will give 24 volt DC from this terminal, and the return is available to the 9th terminal, that is 4-20 milliamp. It will give field. We are connecting it to the field devices, and these field devices, and the field devices we will read process from the field, that is the pressure or transmitter or anything, or temperature or anything, it will read from field device, and it will give 4-20 milliamps to the ninth terminal, that is readed by PLC. See, let's understand how this will work. And the L plus and M is the 24 volt DC. Here the 24 volt DC positive is connected, and the 0 volt DC negative 0 volt DC is connected to the M terminal. Let's see practically how it works. See here. Yes, now we will observe the 24 volt DC is connected to the L plus of the terminal, and the 0 volt DC is connected to the terminal M. And the from terminal 1, 24 volt DC we have thrown it. So we have thrown it up to the fuse terminal. See, here the fuse terminal is available. So fuse terminal is receiving 24 volt DC always from the terminal number 1. So after this fuse TV, we will through 24 volt DC to the pressure transmitter. So pressure transmitter will energize when the 24 volt DC is through to this pressure transmitter. So after pressure transmitter receive pressure, so it will give output like 4-20 milliamps from this transmitter to the 9th number terminal, which is addressed as a AI001. in this case. So what happen when there is a variable pressure? Let's understand the 0 to 10 kg pressure. Pressure is the range of this transmitter. When there is a 0, there is a no pressure, then the transmitter will give 4 milliamps. When the pressure is 10 kg, then this transmitter gives 20 milliamps. So accordingly this transmitter will act. So it is basically depend on the field parameter. What happened, the 4 to 20 milliamps will through from this transmitter from AI001 address, which is addressed as a PLC model, and there it will through to the ninth number of TB. This is how PLC works. There are 8 channels, I said, 1 and 9, 2 and 10, 3 and 11 are interconnected in the PLC. This is how analog input model works. Now we will learn about the new model, that is the analog output model. It is same as the analog input model, where analog input model, what it is, it will give 24 volt DC and receives 420 milliamps from the field devices. In the analog output model case, what it do, it will send 4-20 milliamp to the field device, and 4-20 milliamp from field device, and it will receive from the field devices to return as it require a return supply from field devices. Hence the circuit will close, and the parameter will show in the system also, as well as accordingly the field devices will also act. There are many types of field devices. There may be indicators, there may be VFDs or drives, servo motors. Many type of VFDs and transmitters can be controlled, and the many type of electrical actuators can also be controlled through these 4-20 milliamp. Let's understand deeper about in this section. Let's see how it looks like inside. So the analog input model looks like a same like a digital input model. It consists of a 16 number of terminal, and the L plus and M is connected to the 24 volt DC, and 1 and 2, 3 and 4, 5 and 6 are all are interconnected. So let's see with the practical example how it looks like. See here. So what happened, 0 volt DC and 24 volt DC having two bus bars present in the panel. 0 volt DC is connected to the M terminal, and 24 volt DC is connected to the L plus terminal. So what it do, when the PLC gives output command from terminal number 1, that is, it will give 4-20 milliamps output DC, okay, through fuse terminal, and it will, from fuse terminal it will reach the indicator, and depending of the indicator settings and the current receiving from the analog output model, the PLC will read some value. It may be a temperature, or it may be a pressure, it may be a level, or it may be anything. It may be RPM of the motor or anything, depending on the output model gives the current. It only reads the current, but what we need to do, the process we should understand the process and set in the indicator accordingly, and it will, the 4-20 milliamps will return from the indicator to return to the 2. Hence the circuit will complete circuit will close completely. So this is how digital analog output model will works. And see here, in the next model, in the next upcoming video, I will tell you about this is the fourth part of my PLC training. That's the simulation between the PLC program and field devices. How PLC program it will be done, and how it simulated to the field devices like push button, indication lamp, pressure transmitter, indicator, which are already used in the video number 3. Who has seen the video number 3, they will understand easily how to do the programming in the PLC basic programming, and how push button and transmitter, indicator and lamps will act accordingly. And I am going to train this video in all the languages, that is English, Hindi and Kannada. Now I am posting the videos in English. After completing of all the English videos, 4 videos, I will try to upload the videos in Hindi and Kannada also. So please, if you like this video, please like, comment and share this video with your friends, colleagues, or who are working in the industries, or who are learning interested to learn the PLC. Please do subscribe, so that my video will be updated to you in my next after upload.